Today I'm going to talk to you about some of the new technologies that have become available for us to better formulate our animal feeds. Recent advances in near-infrared technology will allow us to understand this variation both within and between feedstuffs better. We need to look how we can use this equipment to make decisions regarding our feed formulation. And I'm going to look at three different areas of economic importance. I'm going to look at phytate and then energy, and lastly we will look at amino acids. And if we look at the 120 pig feeds here, we can see that phytate P percentage varies from as low as 0.1% up to as high as 0.5%. We can help understand this variation a bit better if we split the feeds into species. So we see here in the piglet feeds, which generally have higher levels of animal protein, the phytate P content is lower. And if we look at sow gestation diets, which have higher levels of high fiber feedstuffs, we can see that the phytate P is much higher. However, the variation within each of these groupings is still more than double. So you need to understand what the phytate P content of your diet is before you make decisions on how much phytate you can add to this diet and what costs you can save. The second area I would like to look at is energy, and particularly energy of different cereals. And this is data from an experiment we're involved in where we fed almost 300 different cereals to different animal species, including broilers, layers, and growing pigs. And this is the growing pig data. And you can see quite clearly here a difference between the different feedstuffs, but you can also see a variation within different feedstuffs. So the variation between the feedstuff is around 1.5 megajoules, and the variation within each feedstuff is also around 1.5 megajoules. If you consider that a megajoule of energy is worth somewhere between 5 and 20 euros in a feed, and we produce more than 500 million tons of monogastric feed per year, then you can see that understanding the energy value of your feedstuff is of big economic importance. The last area I'd like to cover is amino acids, and particularly lysine. As you heat process lysine, it loses its usability for the animal, and what you need to look at then is reactive lysine, which is a measure of the lysine which is available for the animal to use once digested. Here we've analysed around 300 samples of soybean meal, and we find that in good quality soybean meals, the reactive lysine is normally around 90 to 95, even up to 99% of the total lysine. However, if you over-process soybean meal, this reactive lysine percentage can drop considerably. Try to understand the variation within the samples and between samples from different sources. When you have that information, then you can start to make economic decisions that will help you maximize your profitability.